Use of variables. In this module, you will learn about use of variable. We know that perimeter of any polygon is the sum of length of its sides. For example, a square has 4 sides, which are equal in length. Hence, we can say that the perimeter of a square is the sum of the length of the sides of the square, which becomes 4 times the length of the side of the square. Let us write it as 4 times L, which is equal to 4L. Thus, we get the rule for the perimeter of a square. The use of the variable L allows us to write the general rule in a way that is concise and is easy to remember. We may take the perimeter also to be represented by a variable, say, P. Then, the rule for the perimeter of a square is expressed as a relation between the perimeter and the length of the square, P, which is equal to 4L. Similarly, we will understand the perimeter of a rectangle. We know that a rectangle has 4 sides. For example, the rectangle PQSR has 4 sides, PQ, QS, SR, and RP. The opposite sides of any rectangle are always equal in length. Thus, in the rectangle PQSR, let us denote by L, the length of the sides PQ or SR, and by B, the length of the sides PR or QS. Therefore, perimeter of a rectangle is length of PQ plus length of QS plus length of SR plus length of PR, which is equal to 2 times length of SR plus 2 times length of QS. We get 2L plus 2B. The rule, therefore, is that the perimeter of a rectangle is equal to 2L plus 2B, where L and B are respectively the length and breadth of the rectangle. If we denote the perimeter of the rectangle by the variable P, the rule for perimeter of a rectangle becomes P equal to 2L plus 2B. Here both L and B are variables. They take on values independent of each other. That is, the value one variable takes does not depend on what value the other variable has taken. Let us understand the commutative law. To understand this, let us add 2 numbers. For example, by adding 6 plus 8, we get 14. Now interchange these numbers and add. We can see that we get the same answer, that is, 14. This property of numbers is known as commutativity of addition of 2 numbers, 6 and 8. Commuting means interchanging. Commuting the order of numbers in addition does not change the sum. Let us try this with 2 more numbers. For example, what would we get by adding 8 plus 9? We get 17. Now let us interchange these numbers. Do you think we will get the same answer? Yes, here also we get the same answer, that is 17. Hence, this is commutativity of addition of 2 numbers, 8 and 9. Use of variable allows us to express the generality of this property in a concise way. Let x and y be 2 variables which can take any number value. For example, x plus y is equal to y plus x. If we substitute x by 2 and y by 4, we get 2 plus 4, which is equal to 4 plus 2. If we change the value of x by 5 and y by 3, we get 5 plus 3, which is equal to 3 plus 5, and so on. Like addition, commutativity property is used in multiplication also. For example, let us multiply 6 with 3. We get 18. Now interchange the numbers. Here we can see that we get the same number, that is 18. This property of numbers is known as commutativity of multiplication of numbers. Here also, by commuting, that is by interchanging the order of numbers in multiplication, does not change the product. Let us try one more example on this. Let us multiply 5 with 8. We get 40. Now interchange these two numbers. We can see that we get the same number, that is 40. Hence, this is commutativity of multiplication of the numbers. Using variables x and y, as in the case of addition, we can express the commutativity of multiplication of two numbers as x into y, which is equal to y into x. Like in addition, here also x and y can take any number value. They are variables. For example, if x gets substituted by 9 and y by 7, then 9 into 7 is equal to 7 into 9, and so on. Suppose we are asked to calculate 5 into 46. We obviously do not know the table of 46. Hence, here we can use the distributive law, which is the best one of all, but needs careful attention. For example, 5 times 46 can be distributed as 5 times 40 plus 6, which is equal to 5 times 40 plus 5 times 6. By further calculation, we get 200 plus 30, which is equal to 230. This property is known as distributivity of multiplication over addition of numbers. Let us try one more example. 9 times 32 can be distributed as 9 times 30 plus 2, which is equal to 9 times 30 plus 9 times 2. By further calculation, we get 270 plus 18, which is equal to 288. Here also, by using variables, we can write this property of numbers also in a general and concise way. Let x, y, and z be three variables, each of which can take any number. Then, x times y plus z is equal to x times y plus x times z. Use of variables allows us to express these properties in a very general and concise way. Look at this expression, 3 times 11 plus 4, 4 times 200 plus 3 times 10 plus 5. These expressions are formed from numbers like 3, 5, 4, 10, 200 and so on. To form expressions, we use all the four number operations of addition, subtraction, multiplication, and division. For example, to form 3 times 11 plus 4, we have multiplied 3 by 11 and then added 4 to the product. Some more examples of arithmetic expression are 4 plus 5 times 8, minus 6 times 30 plus 9, 6 times 5 minus 4 times 6, and so on. Expressions can be formed from variables too. For example, 6x, 5y, a plus 7, y minus 9. These expressions with variables are obtained by operations of addition, subtraction, multiplication, and division on variables. For example, the expression 6x is formed by multiplying the variable x by 6. The expression a plus 7 is formed by adding 7 to the variable a, and so on. We know that variables can take different values. They have no fixed value, but they are numbers. That is why, as in the case of numbers, operations of addition, subtraction, multiplication, and division can be done on them. A number expression like 6 times 9 plus 4 can be immediately evaluated as 6 times 9 plus 4 is equal to 54 plus 4, which is equal to 58. But an expression like 6x plus 9, which contains the variable x, cannot be evaluated. Only if x is given some value, an expression like 6x plus 9 can be evaluated. For example, when x is 2, then 6x plus 9 is equal to 6 times 2 plus 9, which is equal to 21. Let us see some more simple expressions and see how they have been formed. Look at the following example in a tabular form. Let us discuss two situations on using expression. For example, Rajan has 6 more apples than Kirti. Let Rajan has x apples, then Kirti would have x plus 6 apples. Now let us see the second situation. Rima's father's age is 3 years more than 7 times Rima's age. Let Rima's age be x years, then the father's age would be 7x plus 3. We can see that these two statements are in ordinary language, which can be changed to statements using expressions with variables. Let us revise all that we have learned in this module. Use of variable.